This is Satoshi Society.
Bitcoin is math. Math is not the numbers and letters that you were taught, right? Math is essentially, it uses the letters and numbers to represent energy through time and space. Bitcoin is math, okay? So there's two main components within Bitcoin that we need to understand. Number one being elliptic curve. All right. Number two is the finite field. All right, let's start with the elliptic curve. The type of elliptic curve that's used, and I'll draw it out first, is the SECP 256K curve. And it looks like this. This is a two-dimensional graph, and this is supposed to be symmetrical. I'm not the best drawer. It looks something like this. And it's represented as y squared equals x3 plus 7, okay? Forget that. We're going to visualize Bitcoin without all the mumbo jumbo, all right? Each point on this curve represents a public key. This is how you're identified on the Bitcoin payment network when someone wants to send funds to your person, okay? So you are represented as the public key, and this is on the SECP 256K curve. Each point represents a public key. All right. Now let's talk about finite fields. All right, let's take that same curve. All right, I'm going to draw it a little bit smaller so I have space. That two-dimensional graph, supposed to be symmetrical. Each point represents a public key. Now let's flip this sideways. So this is the two-dimensional graph with the SECP 256K curve. Okay. Now let's expand this out a little bit. So this space right here is going to be represented as the finite field. Let's draw what I call the Bitcoin matrix. So we're going to take this line and apply it to a matrix. All right. Now this right here, we're going to say is what the zoom in is. And these squiggly lines represent a finite field. Now, we'll be talking about the private key. Each point within this finite field space represents a piece of the private key. So when you have a private key, you have about anywhere from 12 to 24 words. Imagine each word as being a point within this finite field. A sequence of points, all right, is 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Each sequence of points is equivalent to a private key. All right. All right. All right. So let me free up some space for me now that we understand that. Now, let me provide you with some perspective on the security of Bitcoin. All right. Just to give you some perspective, the amount of sequences that you can possibly have with each, public key and private key pair amounts to 10 to the 77th options. Okay. Now let's put that into perspective. The amount of atoms in the Milky Way is equivalent to 10 to the 68th power. All right. And the amount, hold on, let me look at this. And the amount of, okay, And the amount of atoms in the solar system is 10 to the 57 power. So this gives you a scope of how many options there are and why it's so hard to hack Bitcoin, right? Now, to provide even more perspective, if you had 1 trillion computers doing 1 trillion computations every 1 trillionth of a second, it would take over 1 billion years to do 10 to the 56 computations. All right, so now you understand why Bitcoin's so hard to hack. No quantum computer is going to mess that up, all right? And we've done even more things to even further security of the Bitcoin network, including changing transaction type from a peer to a pay to public key transaction type to a pay to witness script hash transaction type. But that's a little bit beyond the scope of what we're going to talk about. So let's go into a transaction and how the Bitcoin network functions. So now that we have a understanding of the foundation of the two main components of Bitcoin, now we'll go through a transaction. So a Bitcoin transaction. All right. So we have the script, which is basically the programming language, the compiled programming language that Bitcoin uses in order to formulate a transaction. So we have the pub key, which is the point on the SECP 256K curve. Then we have a signature, which is so basically how nodes identify us when we're sending a transaction to the Bitcoin network. And we use the private key, which we can't basically expose to anyone, because if we expose our private key, then people can take our funds. And so we use the private key, public key, a generating point, and a random piece of data, a nonce, in order to formulate a ECDSA signature. And this is how nodes verify us. And then we have I'm actually using one of the earlier, actually the first transaction type on the Bitcoin network, which is what Satoshi used just for simplicity's sake when explaining this to you, which was a pay to public key transaction type. Now we use a pay to witness script hash transaction type, also known as native SegWit. So we take this transaction and we send it to our Bitcoin node. All right. In our node, we do a Bitcoin CLI check connection count. This is all one word. So this is the command that, so basically this shows visually what this does is it shows how many nodes we're connected to. So this node's connected to other nodes, and those nodes are connected to other nodes, and those nodes are connected to other nodes. So we're relaying this transaction to the Bitcoin network. And then these nodes are connected to other nodes. These nodes are connected to other nodes. These nodes to other nodes, etc. All right. So this is kind of how a transaction looks like. And then I'll actually even go further once I explain what a Bitcoin node is. So now that you have a basic understanding of how a transaction looks like, we'll dive deeper into what a Bitcoin node is. All right. A Bitcoin node, a full node, all right, a full node has a full copy of the ledger. So it goes all the way back to the first transaction on Bitcoin and downloads every single transaction on the Bitcoin network that's ever happened on the Bitcoin network. Then you have some software packages used to verify each transaction to make sure that it's valid. And then software packages in order to relay that confirmed transaction. So after these first two steps, you relay it to the other nodes that each node is connected to, and then it goes further. Each node actually has the option to download additional software packages in order to mine, become a mining mechanism or a wallet. So you can become a miner, and you can also have a wallet in addition to these three functions. Now, once the transaction is sent to each node, so each node now has the transaction in its waiting pool. We call this mempool. Get the point. Now, something I didn't mention actually was that each transaction has a fee, and that fee is what incentivizes the miners to include your transaction into the confirmed Bitcoin block. So the nodes that are miners, so the miners or mining pools, which are groups of miners partnering together in order to increase their energy contributed to the Bitcoin network, in order to increase the likeliness of them hitting the confirmation hash, which then they get the Bitcoin reward, and then that reward decreases every 4 years. So as adoption increases, the mining reward decreases. So the amount of Bitcoin being entered into the Bitcoin network is cut in half every 4 years while the adoption increases. So that's why after a halving event, we see that Bitcoin goes up in price. Kind of going into the supply and demand frequencies that we were talking about in the last video. All right, so these mining pools then pick these transactions and include them into the transaction blocks.